What are the four broad categories of the most commonly used machine learning algorithms? This is a question you should be able to answer at the end of this lecture. One of the most common types of problems that we solve using machine learning is that of classification. Is this email spam or ham? Is this a picture of a cat or a dog? Is this review positive or negative? Classification is a canonical machine learning problem, and in this module, we'll understand the various ways by which we can measure how well our classifier performs. So far, we've only looked at accuracy, but precision and recall are also important metrics to evaluate the efficacy of our classifier. There are also traditional machine learning models such as support vector machines, naive Bayes, which perform very well on classification tasks. However, neural networks have the ability to take on huge data sets and perform classification with a high level of accuracy. Like I said earlier, it's not just accuracy that's important, it's also precision and recall. You'll see that in just a little bit in this section. There are also specialized neural network architectures which focus on image classification, that is, convolutional neural networks, and text classification, that is, recurrent neural networks. We'll study convolutional and recurrent neural networks in the next section. Here, we'll just understand the basics of classification and the metrics you should use to measure your classifier. Here is the basic outline of any application of machine learning. It means you have a huge maze of data where you can't immediately figure out what exactly is going on. It's the job of your machine learning algorithms to find patterns within this data, find insights which would not be available using just simple rule based programming. And finally, machine learning helps you make intelligent decisions based on these patterns, which will help your business or your product. An important machine learning application which proves very useful in our everyday life is emails on a server. Now, the amount of email that we receive has grown day by day, and most of these are spam. You want a good way to eliminate the spam from your inbox. Machine learning algorithms look at all the emails on a server and make the decision as to whether they are spam or ham. Ham is just another term used for emails that are actually sent to you and which are not paid advertisements or something else. Once we've understood what category an email falls into, you can then make a decision as to whether the email belongs in the inbox or in trash. Machine learning algorithms are typically used to solve four broad categories of problems. There are, of course, problems which don't fit neatly into this list, but a vast majority of the problems can be divided into these four categories. The first of these is classification. Classification involves determining the various kinds, classification of images into cats, dogs, and other animals. Sentiment analysis can also be thought of as a kind of classification problem. You want to classify reviews into positive, negative, or neutral. Another common category of machine learning problems is regression. Regression involves predicting a value from a continuous range of values. Predicting the price of a house based on how large the house is and how far away it is from the city center is a classic example of a regression problem. Another example is clustering. Here, we're not looking at labels or values associated with input data. We look at the input data itself and try to find logical groupings which exist within the data. What if you have a huge number of articles, some of which are current affairs, movies, technology, and so on? Clustering allows you to find logical groupings in these articles so that all the current affairs articles are grouped together, technology grouped together, where articles in the same group are similar to each other and articles in different groups are different from each other. Another broad category of machine learning algorithms have to do with rule extraction. If people buy lots of books on your e-commerce site, will they also shop for glasses? People who buy diapers, will they also shop for beer? These kind of implicit rules which might exist within your data, rule extractions are the kind of algorithms which help you find them. Of these four broad categories, classification is very popular and very commonly used as an application for machine learning, which is why we'll focus on classification in this section. And you'll see that many of our example problems are basically classification of different kinds. As a running example throughout this course, we've used this classification problem. Whales, are they fish or mammals? And we've seen that traditional machine learning algorithms are very sensitive to the features that you feed in to the classifier when they make their prediction. However, when you use a representation machine learning algorithms such as neural networks, they're able to determine from the input features what data is important and what data is not. We've also seen that classifiers operate in two phases. The first is the training phase, where we have a huge data set which are labeled with the correct answers. The labels can be categorical variables in the case of classifiers and continuous variables in the case of regression. Machine learning models use this training phase to understand and determine patterns in data, and then machine learning models are typically used for prediction. Prediction is when new instances which the model hasn't seen before is fed into the model, and then it makes its prediction hopefully correctly, provided it has been well trained and is a good model. We've also spoken earlier, so this is just a recap for you of the whole objective of the training phase. We feed in a huge corpus of data that is labeled correctly, especially for classifiers. The ML based model that we're building up will output a classification. We'll check whether this classification is correct or wrong. And if the predicted label is not equal to the actual label, this serves as a feedback to your ML based classifier. And this feedback allows us to improve our model parameters. Now, in problems that we use for prototyping, the way we measure our machine learning model once it has been built, especially for classifiers, is via accuracy. How many of the predicted labels were equal to the actual labels? Now, it turns out that for classifiers, you might have an algorithm that has a very high accuracy, but it's still a poor machine learning model. Are you confused yet? This is exactly what this section will address. It's possible for a machine learning model to have an extremely high accuracy, maybe 99.99%, but its predictions might still be useless. The kinds of problems for which machine learning algorithms are the most popular are classification, regression, clustering, and recommendations or rule extraction. These are four broad categories, and you'll find that most of the machine learning algorithms fall into these categories. This is not an exhaustive list, though. There are definitely machine learning problems which require algorithms such as reinforcement learning and a bunch of others. Autoencoders, dimensionality reduction are also common machine learning problems. However, the four categories that I mentioned right now are the most popular, the most common today.